Okay. All right, so in the book, I'm in section 3.4. I was perusing the homework, and this organic effect caught my attention. I don't know if I mentioned you guys, I grew up in Rhode Island, which is on the East Coast, and I used to have a very different accent until I moved out west, and things like saying my name, Gary Paca, and driving my car around. I stood out too much, and so I learned how to say R's. But once I talk to my mom for an hour, I have a beer, all of a sudden I'm start talking like I'm from Rhode Island again, and we had a bear in the woods, and I saw a bear. Anyway, I grew up in Rhode Island, and my mom was into healthy food, and so we grew a lot of our own food. So back then, this is like the 70s, there wasn't much organic out there. You could go to a farmer's market, but in a store, the organic didn't exist. A study was done where they took a family that did not eat organic, and then they did blood tests on them to see what kinds of toxins related to pesticides and herbicides were in these people's bodies. And so they measured all of those. Then they had the people eat organic. So they gave this family organic food for 2 weeks. And at the end of those 2 weeks, they remeasured for these pesticide, herbicide chemicals. And they were looking at two things. One, was there a difference in particular chemicals? Two, were there less of these substances in the bodies overall? And so I want to quickly look at a couple of these examples. So the first one in problem 3.130 and 3.131, they focus on this chemical called 3-PBA. And here they show a box plot showing the range of this toxin found in this family. So there was a low of almost nothing, a median of a little over 20 micrograms per gram, and a high of over 60 micrograms per gram concentration of this chemical before they started eating organic. After they started eating organic, there was like almost no traceable amounts of this chemical in these people's bodies. One person was an outlier. Maybe that same person up here was still in their body. I don't know what the life cycle of 3-PBA is, but I'm sure there's data out there somewhere. So looking at this, could we say eating organic, you'll have less 3-PBA in your body? And it looks like it's a probable yes, that you'll end up with less eating organic. Scrolling on down. They next actually provide some numbers down in the next example here. So this is the PBA simulated sampling distribution based on this next idea. So far we've just been looking at a single mean or a single proportion. Here they're saying, well, what if we compare the amount of PBA in their system before and the amount after? So now they're looking at two variables, but they're subtracting them and turning them into one. And so let's, somewhere they state exactly what they're doing. Okay, so because this is now a single quantitative variable, and let's see, what is that single quantitative variable? We're going to create a new variable, here we go, by taking the differences in pesticide concentration, by taking the pesticide concentration before minus the pesticide concentration after. Okay, so I'm going to write that down. And then we'll take a look at their data and see what it tells us. Oops. So we have that 3-PBA chemical. And they're looking at let's call it P0, and let's call it PB. So this would be, that's a lousy B, try again. So this would be the proportion of the chemical before, or the amount, let's see, what did they say again? Concentration, okay. And a concentration is I guess it's kind of a mean. We're averaging their concentrations. Yeah, so we got a mean here. Okay, so I didn't do that right. Erase, it's not a proportion. it's the mean concentration before and the mean concentration after. So we're going to go mu for mean before. So mean concentration before. And then they have this mu A, which is the mean concentration after. And they're using those two variables to make a new variable we're just going to call mu, which is the difference. So mu B minus mu A. So that's just the difference before and after. And so what we want to do is make a confidence interval. So I think they actually wanted a 99% confidence interval. Yeah, they want to make a 99% confidence interval. All right, what does that look like? And then they give us enough information to do so. So I need a sampling distribution to make a confidence interval. So here's my sketch. And since I don't have all the original data, I can't do this in stack heap. I would have to find the original data. So here it's my sample data that goes in the middle. And then they want me to be 99% confident. So they want 99% in the middle. That leaves 1% for the tails to share. So that means this tail gets 0.5%. And this tail gets 0.5%. To figure out what values go here and here, they give me a table of numbers hiding here. So this is a percentile table for the bootstrap distribution up here. So 0.5% below is 15.8 difference. So this number is 15.8. And then the other one, 99.5, right, is 32.4. So here's my 99 in the middle, 0.5 to the left. So that means this mark right here, whatever number that is the 99.5th percentile. So this is my confidence interval. So what this says is the mean difference in concentration is somewhere between 15.8 to 32.4. Since it's before minus after, that means they have somewhere between 15.8 and 32.4 less micrograms of this substance in their bloodstream. Now, someone might ask does it make a difference eating organic? Well, if it didn't make a difference, then this mu B minus mu A would be 0. It would be the same number, and we subtract them and we get 0. Is 0 in this confidence interval? Question mark. Answer is no. 0. If that's 15 and that's 32, 0 would be way over here. It ain't in the interval, not even close by a long shot. So, does eating organic lead to having less 3-PBA in one system? The answer is yeah, it seems to based on this study. Okay. Here's the other interesting thing. I know we're about out of time, but I thought this was super exciting. Partly because I grew up eating well. I strayed for a while, but then I kind of went back to it. I try to eat well, best of my ability. Yeah, this one right here kind of blew my mind. So when they check someone's blood, you know, there's some things that are easy to check for, there's some things that aren't. And when they did this study, they were checking for 240 different pesticides that might be in a person's body. Before the organic food, they found 111 of these 240 different pesticides in the people's body. After eating organic, they found 24 out of 240. Question, is that a significant drop in the proportion of pesticides found in people's bodies? Well, that's a tricky question. And the only way to test that is to look at the difference of those to see what happens. And so that's what they were looking at down here. And we asked the same question, right? Is there a significant difference between these two? So this is the distribution right here. And then we say, okay, well, is it possible there's really no difference and this is just weird? And so I look at the differences down here. On average, the difference was about, what's that, 0.37 maybe, 37% drop in the number of these 240 chemicals. Is 0 no drop in this interval? Well, if that's 0.25 here and that's 0.45 here, 0 ain't in this interval, meaning there is a difference, right? What you eat matters. These chemicals that end up in our body can be dangerous. They lead to things like liver problems and cancer. Okay, so, but here's the other thing. Remember that Happy Planet Index data a bunch of people looked at? There is a relationship between life expectancy, happiness, and average income. What if people can't afford to eat good food? It tends to be more expensive. It ain't cheaper. That's a problem, right? So is poverty a reason people might have more toxins in their body? The answer is unfortunately, yeah.